Hello everyone, I am Somnath Kormukar, a senior Python developer and data science specialist. This channel is designed to provide a structured end-to-end learning path from core fundamentals like statistics and Python to machine learning, deployment, and advanced topics in generative AI. My focus is on practical understanding, building real projects, solving real problems, and developing skills that translate directly into industry applications. If you are looking into a real roadmap to grow your career in data science and AI, you are in the right place. Okay? Let's start. So today I will start with the ABCD of the data science. Okay? Very fundamental thing. Okay. So step by step I deep dive into data science, and I will try my best make this tutorial easy as possible. So first question is, what is data science? Actually, data science is a, you can say, is a process. Okay, like first you need to collect the data, understand the data, find the patterns, and making decision on or predictions. Let's take real life example: online shopping. Okay, so companies collect data on what user click, buy, and spend. A data scientist answer which products sell most, which user will buy next, how to increase overall sales. So this kind of actually information is usually need by the marketing manager, okay, the business team. So this kind of data actually find out from the data, raw data is the main task of data science. So one example, many use cases, different use cases is there. So step by step I explore all these things. Now the data science process, I'm just explain each step briefly. Data collection. Get data from files, apps, database, okay. Maybe many other sources as per uh, business. Okay. We have to collect all data. Now next is the data cleaning. So data, as we are collecting data from different sources, sometime it's a high chance data in actually in not in correct format. Okay, some data actually some junk data present in the files. Okay, some unwanted characters present. So we need to remove all those things to make the data clean so that easily can we can analyze the data. Also, next step is data science analysis. It's a main very important part. Here actually we applying different mathematical formulas, okay, statistics method to find the patterns, okay, which pattern, for example, which product sells most, okay, like this. Next is modeling. Now it is the final step, we can say it's a build model with the help of the collected data, collected clean data. Okay, so that whenever we got new data and clean it and pass to the model, and it will say it will predict the future. Okay, so here actually we are learning the machine. Okay, to predict something. Next is the visualization. It's very important thing as well. So it will show the necessary graphs. Okay, the dashboard so that business person can understand their data, and they can take the necessary step to uh, grow their business. Okay. These are the main fundamental steps. Now moving towards the essential skills. Okay, what actually need to learn data science is the actual thing which actually aiming to teach you. So Python coding or R-line coding. Okay, so, but I prefer the Python because it's the most popular and very easy to learn. Basic Python knowledge is enough. Okay. Don't need very advanced knowledge. Okay, don't worry. And in my course, when I show you the example, I will I will try to explain the code so that you can understand. Okay. And these are next is a statistics. Don't worry. Statistics here mean it don't actually you don't need uh, all the statistical mathematics. You have to go in very good in the statistical mathematics. You have to practice lots mathematics. No, we just here you have to just get the brief idea. Okay, if you have idea, then it will be okay because here you don't need to mathematically calculate anything. Lots of Python functions available you can use to calculate. Okay, just you should have the basic idea of the statistical different uh, functions. Okay, formulas so that you can use it. Okay, so next is the machine learning. Yeah, it's also important to build how to build a model. And next in last one is the business thinking. Definitely, to analyze the data, you should have some domain knowledge. Okay, so for online shopping, you have to know that actually what actually target your target, what is happening. Okay, so this is a basic idea you should have. Now coming to real world use cases, you can see sales prediction, fraud detection, recommendation. Okay, sales prediction, yeah, from the uh, various sales platform, we can collect the data and analyze it and then predict. Fraud detection, yeah, also it's possible. I'll explain it later when I'll show you the I'll create a small project. Okay, I'll create many small projects that you can get hands on. Okay, and clear you should have I mean you will have a clear idea about everything. Now is recommendation. Yeah, in the online shopping like Flipkart, Amazon, and you'll find that uh, apps will suggest you some, but based on your historical purchase. Okay, this was actually done by the data science. Now coming to the main part, it is a descriptive statistics. Actually, in this portion, I'll only discuss what actually need in data science. I'm not going to describe many things which actually rarely used in data science. If come across those things, and that time only I'll explore those things. But here I'll discuss only the main thing. Okay. So what is this? The descriptive statistics help us understand data distribution, detect critical outliers, and support exploratory data. Do not have the outliers. For example, in a company, the salary is such a the salary of the employees like 10, 20, 25, 15. Okay, the maximum salary, usual salary for 95% or 99% employees is around 30K. Okay, but if anyone, I mean, if anyone or higher level got the salary like 5 lakh per month, you see that so maximum percent of employee salary below 30, but 1% 5 lakh. Just just see the difference. Okay, okay. This is called the outlier. Outlier means that when sudden big changes comes. Just compare 30K and the 5 lakh. Big difference, huge difference. This is called the outlier. Okay. So I'll explain later as well. Now that let me tell you what topic I'm going to discuss in this part. I'll discuss mean, median, mode, variance, standard deviation, percentiles, quartiles, skewness, and kurtosis. These four thing section I am going to discuss. Let's mean. Mean is nothing. Very simple. Is the average. Let's take the example of the salary. Okay, this is salary data. Okay, 20 here 22 means 22K. Okay, in thousand you can say 22,000 per week. Okay, so here see the most of the employee salaries like this, but the red color number see very extreme. Okay, this is actually outlier. Okay, now the mean is 48.8. Mean average. We have calculated average. You will get the average 48.8. But just think about if you say that average salary is 48 or 49 about, is it not misleading? You can see here maximum salary range is below 45, but yes, average is saying high, right? Suppose you walk into a company and you uh, ask manager what is the average salary of your company, and manager says that yeah, our company salary is around 50K. Is it right? But if you just go reach one-to-one employee one-to-one and ask the salary, you can then find that some with 22, 25, 28, 30, okay, like that. But here manager is saying that around 50K. Totally wrong. Actually, what happened? This one person actually taking huge salary. Actually, this is actually uh, misleading the actually the average or pull the average upward. Okay, so this is a mean, and also I have shown you the problem of the mean. If you in type this type of scenario, if you take the mean and you'll get the wrong information. Okay, that means in data science, if you want to know that the average thing of any data, then if you take mean in this scenario, you will get wrong value, right? Because the extreme value is present. There is a when you see data is normal format, like no extreme value like 50, 60 is a normal value. Okay, in that case you can use mean. You can say take example like exam scores. Okay, usually in exam, any exam scores usually there's a no extreme value, right? And stable sensor reading. This means actually I'm talking about the sensor data, like temperature sensor. Also same. If you take data from any temperature data sensor, not then this also not actually temperature vary from 1 2 degree, right? Maximum 5. The data also in normal format. So when to avoid mean, that is as we have told, data is heavily skewed or is a outlier or skewed or outlier. Okay, like salary distribution, national income. Yeah. So this is the mean. Now going to the median. Median actually true center. Now if I take this data and try to center of the data, actually for that we need a sorted data, right? It is a sorted data. Now if we pick that middle one, the middle is actually 35. Okay. Mm. Now if anyone asks you to average salary, if you say 35, now it's correct. So if the data has the outlier, in that case you can take the median. Okay. Now there is a mode. Mode is actually uh, is tell you the most common value, most popular value in data set. Okay. Suppose I'm taking example of the sales. It's this salary is suppose this is a salary data. Okay. 20, 25, 25, 30. Okay. Then in that case, 25 is the popular because most frequent 2 times, but are the rest of the thing. So actually, this mode I tell you the what is the common salary employee gets in a company. Okay, it's the average. I mean, this is like average kind of data. It's a true, but it is a common. Median is a true thing, and mode returns the common thing, which is the common. This salary is a common to employees. Okay, understood? So what is a mode, median, and mean? Now coming to variance and standard deviation. What is variance? Variance actually measures the how far individual value are spread out from the overall mean. Mean is the actually I've, I've told you here is the central point, average point. It's the average. You can assume the central point of the data. But for the data have outlier, In that case, no. So high variance means data points are widely spread out. And low variance means data points are tightly packed. I'll show you why you use is a disk analysis, baseline stability. Okay, this kind of analysis. I'll later on. I'll whenever I'll create a small ML model, that time I'll discuss in details. Okay, so variance is a spread of data. Now, and let me show you one thing regarding the variance. So then see that there is an example data set 50, 52, 49, 51. And see all the numbers are very close to each other, right? Only difference 2, 3, 2 or 3. Okay, this is called low variance. And yes, and in the below you can see 10, 50, 90. The distance is very high, right? This is a high variance, very spread. Okay, it is hard to analyze, but it's easy to analyze. You can see for the high variance, you can see the wide spread, but peak is low. For low variance, peak is high, width is low. Width is low. Okay, this is the graph view of the high variance and low variance data. Now standard deviation. A standard deviation is the average distance of values from the mean. It actually help you to understand the variance. Okay, it's much easier to interpret than variance because it remains in the same unit as the original data. Okay, actually variance is in a graphical format, but here the standard deviation is a numerical data I will give you. Okay, used for financial risk assessment, quality control margins, machine learning, feature scaling. I'll explain all this thing later. Okay, later tutorial video. Now let me what is standard deviation? How much values deviate from away? Move away from the average. Let's take example. There is a 10, 12, 14 is a data. First, you need to find a mean or average. This is a 12. Now, need to find a distance from the mean for each value. Value 10, 12, 14. Now, if we do 10 minus 12, it gives minus 2. This is the distance from the mean. Similarly, 12 minus 12, 0. 12 minus 4, 14 minus 12, 2. This is the distance from 12 mean. Okay, minus 2, 0, plus 2. Now, squaring the distance. Minus 2 cos square 4, 0. Why square? Actually, square will uh, omit the negative, remove the negative, because if we add some these things, it will cancel out the 2 because there is positive and negative are present. That's why we are squaring the distances. Now again taking the average of the distance. Actually, to as we have to average of the distance, that's why where we just did the square, because the negative mislead our value. Okay, so now we got the average. Now we'll take the square root. And now we back to the original scale of the data, right? This is the original scale. Back to the original scale. So this is the distance, average distance from the mean of the element. Okay, this is how we calculate the standard deviation. Now go to percentile and quartiles. Actually, percentile is answer the where does most of the data actually lie, rather than just observing the average. Okay, for the big data set, this is a salary data set. Okay, if you if someone query about the salary, how your company salary, employee salary. So in that case, if you just tell the average, it's not actually not enough to understand the actual pattern of the salary pattern of the employees. Okay, so if you tell like this, yeah, 25% of our employee get this type of salary, 50% of our employee get this type of salary, 90% employee gets this type of salary. So in if you tell someone in this way, actually they can better understand the salary structure, right? So in that case, we should use percentiles and quartiles. The percentile is this thing. The 50 percentile means 50% of data lies between these. Okay. Here the example for this example data set is a 50. Actually, data is in order. That's why this quite percentage and value is same. Percentage and value is same. Okay. Your 10 value is present. So below 15 obviously 50, 90, obviously 90. It is example. Now actually what is quartile? Quart means actually 4. Quart means 4 and tile. So we have to split the data into 4 part. Okay. Quartile means split data into 4 part. So first quarter 20% or data, while 20% data live. Second quarter is 50% data live. That's when in the point, while 25% data lies. Same for 50% data lies in the point. Obviously, actually median will tells you median is the actual number. In that case, for quarter 2, median means middle value. Left side of the median, obviously, the 50% value lies, right? And the third quarter is 75. So, and remaining in the quarter 4, Q4. Okay, this is a format 25, 50, 25. Let me tell you more clearly. We need the value where 25% data lies. We need a value where 50% data lies. We need a value where 75% data lies. Let me show you your data set like this, as I told. Now cutting the data set into 4 parts. Okay, quartiles means divide data into 4 equal parts, right? As I told before. So in this way, it's a pictorial view. dividing Q1, Q2, Q3. Okay. Now step by step do the thing. So first we have to find a median. Actually, median is a Q2, right? Because I say 50% of data, median Q2 is a 50% data. Obviously, median means middle. Yeah, middle is a point where in the left side of the median, the 50% data lies, or the sorted one, right? It actually works on the sorted data, sorted, not unsorted data. Value should be in short, right? So for this data set, as the even number, so 50 and 60 to take two value and then average. This is 55. So here the median is 55. That means this is a Q2 also point. So, so below 55 is where 50% data lies in this portion. Sorry, this portion, right? So we got a Q2. Now I need to find a Q1 and Q3. Now split into two halves based on the median, left half and right half. Okay. Now let's find the Q1. In the left hand side, again taking the median. That is 30. That means 30 is a point of Q1, right? Rest is part of Q2, right? Now find the Q3. The right side, let's take the median, same process. So Q3 point is Q3. Remaining is the Q4. That's all. I hope you all got the answer. This is the actual quartiles. So Q1 30 means 25 data is below 30. Q2 40 means 51 data below 50, 55. And Q3 80 means 75% of data is below 80. So this is enough final picture. Now coming to the skewness and kurtosis. Skewness is actually measures the asymmetry of the data distribution. Two types of skew, the right skew, left skew. Right skew means long tail stretches to the right. Left skew means long tail stretches to the left. What is this? Actually, I was celebrated as it. We have seen already that the 200 outlier is present. So in that case, that is right skew due to the massive 200k outlier. Right? Actually, this skewness helps us to decide whether we should take mean or median. Right? It's a process of the uh, choosing the understanding the outlier. Okay. Let me show this skewness. This is normal, no skewness. Normal, no skew. Left and right both are same. This is a median point. Okay, here mean, median, mode, all equal. Okay, here you can see the positive skewness. You can see right portion is long. This is a negative skewness. Here left portion is long. Is some negative point value present in your data set, or very low value present in this data set. Then in that case, your data point will be moved towards the right, left. This is a pictorial, the skewness. Now the kurtosis. What it measures how heavy or light the tails of the distributions are. I mean, there is a high kurtosis, low kurtosis. See, where is the presence of the stream outlier. Low frequency limit indicate the smoother, more uniform data. This is for risk outlier detection, identifying the anomalies in fraud analysis. Okay, so let me give you the example. Before that, let's show the graph first, the pictorial format, and see red one. Peak is, tail is very high. Scores moves from shoulder into center and to beat a tails. Okay, these are leptocortic, mesocortic, blue one, and green one, platycortic. Actually, 3 is used because here you can see we are comparing the 3. 3 is used because normal distribution has kurtosis equals 3. So it becomes a reference point to the compared other distribution. A later I'll come the normal distribution thing. Okay, don't worry. Just for this time, just have the basic knowledge on it. What is this? The skewness, which side is straight, and kurtosis tells how extreme are the tails or outlier. Now, simple dataset A and dataset B. Okay, you can see both have the high value present 100, in that case 1000, very big. Both are right skew. Okay, because rest of the value is similar kind of, but the right value is extremely big. Okay? So both are right skew. Skewness is positive, right? Because right skew is positive and left skew is negative. A has moderate extreme value and B has extreme, right? Extreme 40 and 1000, very big. And if I kurtosis distinguishes them like normal or moderate tails, and B high kurtosis, heavy tails, more risk. So let's compare. Suppose you bit confused because as kurtosis skewness tells the same thing. So why you need both? Okay, because skewness also tells the outlier, kurtosis also tells the outlier. But why we need both, right? So only skewness. Suppose only taking Euclidean. So what we can know? You know, data lens right, but outlier mild or extreme we cannot know. Okay, we have, we will not be able to know the how much outlier is there. We know the outlier is there, but how much is there, we'll miss it if we not use the kurtosis. Only kurtosis, what is, we'll know that tails are heavy. Okay, but don't know are extreme or left or right. That means we know that is extreme outlier is present, but we'll not be aware whether it's a left or right. I mean, this outlier for the extreme value, extreme high value, or extreme low value. Okay, so that's why these two things is very needed. So that is all for this tutorial video. And if you have any question, you can post in my channel. So I'll ask you, or in the next video, I'll explain all the answers there. Thank you.